So today we're going to talk about crystalline versus amorphous solids. Your topic is crystalline versus amorphous. Your goal: I can compare and contrast the two main types of solids. There are two types of solids, and what makes them different is the structure that makes up the solid itself. So first we're going to talk about crystalline. They are the most common types of solids. They are firm, hold a definite and fixed shape, are rigid and incompressible, and they generally have geometric shapes and flat faces. So you do need to know crystalline solids. Go ahead and underline that, highlight it, and what's underlined on this slide is what you need to know about that. Some examples of crystalline solids are like your diamonds, most of your metals, salts, things that kind of form a crystal-like structure. And then you have amorphous solids, which are rigid structures, but they lack well-defined shape. They don't have like the geometric shape that you see with diamonds or salt or anything like that. The most common examples of amorphous solids is like your glasses, gels, plastics, polymers, wax. So things that have a more smooth surface instead of a rigid surface like crystalline solids. So geometry and structure, you need to know that amorphous solids do not have ordered structure and they lack any pattern or arrangement, which is why they're a little bit smoother. They don't have the different faces or the different sides, whereas the crystalline solids do have definite and regular geometry due to the orderly arrangement of the atoms. You also need to know that amorphous solids do not have a sharp melting point, whereas crystalline solids do have a sharp melting point where it changes to the liquid state. You also need to know amorphous solids have no characteristic of heat effusion, thus regarded as supercooled liquids or pseudosolids. Crystalline solids have a definite heat effusion, thus regarded as true solids. Amorphous solids are isotropic, which basically means they have the same physical properties in all directions, whereas crystalline solids are anisotropic, which means their physical properties are different in different directions, and that's because crystalline solids have different sides and angles, whereas amorphous is the same all around. Some examples: amorphous glass, organic polymers. That's also where you get like your waxes, your plastics, and then your crystalline solids are like your diamonds, quartz, silicon, salt, and different metallic elements as well. Amorphous solids have covalently bonded networks, whereas crystalline solids can have covalent, ionic, van der Waals, which we didn't really talk about, and metallic bonds. The arrangement of the atoms. So you can see here, crystallines, they all is very rigid shape, very straight across, very compact. Polycrystalline, which is kind of a mix of both crystalline and amorphous. It's still put together, but there's some pieces that are kind of switched or changed where you see different angles. And then amorphous, it is not structured as rigidly as crystalline, which gives it its different properties. All right, so that's it for this section. Make sure you fill in the Venn diagram that's in your digital notebook on the next slide. You'll need at least 4 things for crystalline, 4 things for amorphous, and then 2 things for both. Let me know if you have questions for anything, and I hope you have a great day.